Physics Part 89. Well, the force causing this acceleration is gravitational attraction of Earth on the objects, or the force of gravity. The force of gravity which acts on an object is called the weight of the object. We can apply Newton's second law to the weight for a body of mass m falling with the acceleration of free fall g. The weight W is given by W is equal to mg. The SI unit of force is Newton, and this is also the unit of weight. The weight of an object is obtained from its mass in kilogram by multiplying mass by the acceleration of free fall. 9.8 ms. Thus, a mass of 1 kilogram has a weight of 9.8 n. Because weight is a force and the force is a vector, we ought to be aware of the direction of the weight of an object. It is towards the center of the earth. Because weight always has this direction, we do not need to specify direction every time. We give the magnitude of the weight of objects. The weight of a body is an example of the force acting on a mass in what is called field of force. Near the surface of the earth, this field is approximately constant and uniform. This means that the calculations, we can take the same value of g, whatever the position on the surface of the earth or for a short distance compared with Earth's radius above it. There are other sorts of fields of force. An important example is an electric field. An electric charge experiences a force in an electric field. There are significant similarities between the behavior of a mass in a gravitational field and an electric charge in an electric field. We shall explore these similarities in upcoming chapter. How do we measure mass and weight? The unknown weight of the object is balanced by a force provided by the spring in the balance. From a previous calibration, this force is related to the extension of the spring. There is the possibility of confusion here. Laboratory Newton balances may indeed be calibrated in newtons, but all commercial spring balances, for example, the balance at fruit and vegetable counters in supermarkets, are calibrated in kilograms. Such balances are really measuring the weight of the fruit and vegetables, but the scale reading is in everyday life. The average shopper thinks of 5 kilograms of mangoes as having weight of 5 kilograms. In fact, the mass 5 kilograms has a weight of 49 newtons. The word balance in the spring balance and the laboratory top pan balance relates to the balance of the forces. In each case, the unknown force, the weight, is equal by a force which is known through calibration. A way of comparing masses is to use a beam balance or lever balance. Here the weight of the object is balanced against the weight of some masses. We have previously been calibrated in mass units. The word balance here refers to the equilibrium of the beam. When the beam is horizontal, the moment of the weight on one side of the pivot is equal and the opposite to the moment on the other side of the pivot. Because